Just because we have fractional exponents doesn't mean that anything is more complicated or changed. The rule says subtract when we have like bases being divided. So this becomes r to the 2/3 minus 1/6 power. And remember, that happens in the numerator. Now, I can't subtract fractions unless I have a common denominator, so I'm going to go down here and I'm just going to do a little common denominator work. So that's 3/6, which is 1/2. And so this is really r to the 1/2 power, which would be an acceptable answer, or you could have r square root of r. Those both would be acceptable answers. In the same way, like bases of 8, that means I add those exponents, so I have 8 to the 8/2, which is 8 to the 4th, which you could leave by itself, or you could go ahead and multiply that out and you will end up with 4,096. And again, either one of those is an acceptable answer. Now this initially looks like you can't do anything, but again, like I said in part 1, simplify all of your numbers. And I know that 81 is 3 to the 4th to the negative 3/4 power. Power to a power, I multiply, so when you take that problem out and you think about multiplying your exponents, that's your multiplication. These are going to cancel, so you're going to be left with 3 to the minus 3. Well, a negative says, please move me, so I have 1 over 3 cubed, which becomes 1 over 27. But either one of these is an acceptable answer. Just remember, we never leave negative exponents. Now the square root of negative 99, prior to this chapter we would say no real answers, but now we know that this is really 1 times, and if we factor this, 9 times 11, negative 1 times 9 times 11. So when we go through our standard procedure, what's the square root of negative 1? That's I. What's the square root of 9? That's 3. Can I take the square root of 11? No. So my answer is 3i square root 11. Because remember that key math fact that I squared equals negative 1, and the square root of negative 1 is equal to I. Now continuing on with that I work, this is just a multiplication problem. I have negative 20i squared, so I have negative 20 times negative 1, and so I have positive 20. In this is a FOIL problem. There's no sign right there, so I'm going to go ahead and I'm going to take first two terms times each other. So I have 32i squared, last two terms times each other, plus 12i, inside terms minus 48i, and my last terms are minus 18. So we have to go ahead and do our cleanup and our combining like terms. So I'm going to have 32 times minus 1. These two are going to combine for minus 36i minus 18. Negative 32 will combine with negative 18 for negative 50 minus 36i. And that is your simplified answer. If you're foiling with i's, you're usually going to end up with a two-term answer. So we're going to go ahead and practice another FOIL problem. Notice I have these two set up so that you see the difference between foiling and a subtraction problem. So go ahead and FOIL again. I have 12 first term plus 18i outside term minus 20i inside term minus 30i squared. 12, combine these two, minus 2i minus 30 times minus 1. Well, that becomes positive 30. 30 plus 12 is 42 minus 2i. And that's your final answer there. This one, I'm subtracting that quantity, so remember that's plus a negative 1, so I really have 3 minus 5i plus negative 4 plus negative 6i, because that negative gets distributed, but it doesn't turn into multiplication, it continues to be addition. So 3 and negative 4 are negative 1, negative 5 and negative 6i become negative 11i. And there is your final answer for that one. I's behave in the denominator just like radicals, so this is bad grammar. I can't do that. So I have to multiply by that conjugate, which is 1 minus 4i. Again, I don't care what the numerator is. I'm just caring about cleaning up that denominator. So both of these end up being FOIL problems. So I'm going to go ahead, and in the numerator I have 3 plus negative 12i plus I minus 4i squared all over 1 squared minus 4i plus 4i minus 16i squared. So when I go to clean things up, I have 3 plus combined like terms negative 11i. This is negative 4 times negative 1, so I have plus 4 all over 1. These two drop out, and I have negative 16 times negative 1 plus 16. So I have 7 plus a negative 11i all over 17. Take a quick peek. Do 7, negative 11, and 17 have anything in common? Nope. That's your final answer. Now, simplifying single powers of I, remember we're going to break that up into groups of 2. So how many I squareds are in 62? Well, there are 31. Power to a power I multiply. I squared is negative 1 to the 31st, and if I take negative 1 to the 31st power, I get negative 1. This is a conjugate problem again, so now I need to multiply by 3i plus 2, because I need the opposite sign, all over 3i plus 2. This time it's just a distributive property, so I have 15i squared plus 10i all over first two terms, 9i squared, outside terms, 6i, inside terms, positive 6i, last term minus 4. So in the numerator I have negative 15 plus 10i all over 9 times minus 1 minus 4. Clean things up, negative 15 plus 10i all over negative 9 minus 4 is negative 13. There are no common factors between 10, 15, and 13, so I'm done. This example here, it's tempting to want to multiply by 4i, but you really don't. You just have to multiply top and bottom by I. So my top becomes 7i, my bottom becomes 4i squared, which is 4 times minus 1. So it's over negative 4. If you do go ahead and multiply by 4, then you just have some simplifying to do at the end. That ends the review. Good luck on your test on Monday.